Well, howdy everyone, Mr. Troy here. I thought I would do a quick video to show you an alternate way to find determinants. This is the method referred to as using minors and cofactors. And it's how you're going to find determinants for matrices that are larger than 3 by 3. So we're going to start by considering just the top row. Okay, the elements of the top row are 1 and 4 and -3. Now, I want you to think about the matrix that is formed if you eliminate 1's row and column. That matrix would be 5, 4, 3, -2. And we're going to do the same thing for 4. So that matrix would be -2, 4, 0, -2. So think about it as the 2 by 2 matrix involving these two and these two. And finally, the 2 by 2 matrix excluding the row and column of -3 up there. That would be -2, 5, 0, 3. Okay, so the way that we're going to find the determinant is we're going to take these smaller determinants, some people call them subdeterminants, and we are going to multiply by the entry that we used to find them, or the entry that we kind of excluded its friends to find them. Okay, so 1 times the determinant of 5, 4, 3, -2, 4 times the determinant of -2, 4, 0, -2, and -3 times the determinant of -2, 5, 0, and 3. Then, if the row and column of the entry is even, we are going to add. So first row, first column, that makes 2. So we're going to add. First row, second column, that makes 3. We're going to subtract. First row, third column, that makes 4. We're going to add. So 1 times this smaller determinant, and this is just done because these smaller determinants are faster to find. So -10 minus 12, that's -22, minus 4 times 4 minus 0, that's 4. And in this case, it's going to end up being minus 3 times -2 times 3, that's -6. So we've got -22 minus 16 plus 18, that's -20. Now, I want to show you the power of using this method. And the power of using this method is that you can choose which row to use or even which column to use. So now I'm going to expand along the first column. Okay. Now the reason I would choose this is because now my elements are going to be 1, -2, and 0, which means I'm not even going to have to do a calculation here. I'm going to add the first row, first column, that's even, so 2. The first row, or sorry, second row, first column is 3, so I am going to subtract that. And then my determinants, or my matrices, are going to be 1 if we exclude that row, so 5, 4, 3, negative 2. And then with this minus a negative 2, we're going to use 4, negative 3, 3, negative 2. And then remember, we had a 0 for the other one, so we're just ignoring that. So those small determinants are negative 22 and 1. So negative 22 plus 2 times 1, that's negative 20. And we can see that that gets us the same thing in any way. So that is how you can expand upon a row or a column to find a 3 by 3 determinant. I thought the red example was a little bit easier, and that was because I had this 0 here that meant I didn't even need to find that particular determinant. I'll do another video on 4 by 4 determinants. So once that's uploaded, I'll put a little card right here. Maybe. All right. Hope that was helpful. See you later.